So I'm making another mediator device, and this is the paw pad. And each of the lead wires to the paw pad goes to one of the three keys for one of the three colors of the frequencies that go to the signal, mediator signal generator, for this light signal communicator. Take the angular pliers and snip off a little piece of solder. Put it onto the contact. Contact plate. Use aluminum foil underneath the contact plate because it helps with the making sure that the filaments of the end of the wire filaments at the end of the wire do make a metal on metal contact necessary for a good electrical connection, circuit connection. When you're handcrafting something like this, little details in the fabrication of the metal parts can make all the difference on whether or not the circuit is going to work or not. Now I use the soldering iron to make sure to melt that solder underneath there between the end of the wire and the contact plate. That's good. Tighten it up a little more. That should work. And a little tighter. Okay, that should be pretty solid. copper, yeah, so here's the copper end. And here's the torch that it goes to. LED. An LED torch. I snip out, I use the use the Dremel to make 4 cuts, 1, 2, 3, 4, around the box of the switch, and I just use the angular pliers to tease it out, and once I cut it with the Dremel and get the switch out, so I have the leads to the switch on both ends exposed. So that's how I put in my own different switch control, which is the one for the paw pad for the 3 frequencies. Okay, so now then I want to make sure that I get a good electrical current connection. So I cut out a little cut of aluminum foil. And I cup it underneath where the wires have been twisted together to be soldered. And then I get the solder you have to do this in a well ventilated room with, I've got a fan overhead, because you don't want the fumes from the solder to affect you badly. I wouldn't want to be doing this kind of soldering all day long as a single function unless I had a really well ventilated room and was wearing some kind of respiratory protective stuff, because there is definitely some risk of toxic fumes with soldering. It's always part of the industry risks that people in the electronics industry deal with all the time. It's systemic in this industry. And if you're an engineer, you want to try to keep your math brain intact, your hard logic brain, so toxic fumes. Breathing toxic fumes all day is not helpful to that purpose. So kind of want to try to avoid that if you can. And of course, the necessary work you got to do. Try to not breathe the fumes from the soldering. Okay, so now with that aluminum foil around the wire ball that you wound up, it looks like it's a pretty reliable connection there on that one. Now we go to the second one, which the electrode falls out after you remove the switch. So we'll have to put that back in very gingerly. Here is the ground from the paw pad, which you have to 3-branch the ground when you get to the torches. So that you only have 4 wires you have to deal with leaving the paw pad. 3 for the leads and 1 for the ground, leaving the paw pad. But when you get to the torches, the 1 for the ground has to branch into 3 for each of the 3 torches, for the 3 frequencies, which are the signal frequency basis of the whole mediator communicator system. And there's a sound in the background of an airplane because I don't live too far from the city airport, and not the municipal airport, but the city airport. So sometimes at night like this, there's an arriving twin engine or quad engine aircraft, probably some kind of delivery company, and it's coming into the city airport at night like this. Overnight delivery of some kind. And cut myself a little aluminum foil wrap just to make sure the electrical connection is going to be a good electrical connector. And get the solder. This time I'll use the clamp, the solder clamp. Where is it? There it is. Kind of a delicate little task here with this one. Smaller wire. And that didn't work quite like I intended it to, but we'll adapt. And the foil wrapping fell off, so I'll just have to rewrap it by hand. And get some tape around there to make sure that it holds. Not too much tape because that would make it too thick. Again, it's like you have to be really kind of finessing the materials. It's a real craftsmanship getting this done right. Okay, so now then I have to pull this down through back into its proper place at the bottom of the battery casing, so that the touch plates will match up with each other the way that they're supposed to. And good. Now I hold my finger down there to hold it into place now that it's lined up right. And I put the button back into the casing because that actually puts pressure on both plates to hold them into place. And it's rubber. The button depressor part is rubber, so it's dielectric, and it'll separate them and keep them separated. If things move around here in the course of operation, they're separated and they won't short each other out. So now then, electrical tape to wrap things into place, hold them into place. You kind of have to try to make the assembly that you're making here, you're fabricating, because you're modifying the previous original design. Try to make it so that it's a little bit shock-proof and jostle-proof, and won't simply go goofy on the operator that gets the mediator, because they won't know how to get in there and fix this if it does. So now that is the red touch plate, and there it is, it's working. So yep, I got the circuit complete on the third of the 3 torches. So now I take the paw pad out of the grip, the vice grip, and you have to line up these the 3 lead wires off the touch leads, and you have to use the electrical tape and some duct tape to put down some binding on the wires around the paw pad so that they don't get jostled loose by the operator when they get the mediator. Because people will drop the paw pad, various things will happen, so you need to try to make it a little bit capable of some shock, some bumping around. Okay, so the ground side has all 3 keys connected by a single base because it's the ground, it's the common ground. Let me go ahead and put the batteries in. See, so put the batteries into the battery holder. So I've got all the batteries in there. They're AAAs, 3 AAAs. And you place those in the battery holder part. Screw the end on. And since you replaced the switch with the paw pad switch, now you have your three frequencies. And what's happened to the third one here? There we go. Okay. On this one, I can see that what I want is I want to have okay, that'll stay. That'll stay. Yeah. Okay. So then you have to get your cylinder mount, and this is what the three torches go into to make the three sides of the triangle, which you draw on the clear plastic end here. Shapes that make up the defining three sides of the triangle referentially for the perceiving eye that is going to see the signal coming through the mediator. The human eye has to be able to register and recognize what's called position effect in the signal, whereas the computer will be paying attention to frequency of the three different torches. So, from completely different points of reference on the signal, the same message is being communicated in one way to the human eye and brain, the way that our brains work with our eyes, and in another way it's doing a machine language that the machine learning system of the computer is capable of dealing with. So it's distinctly two different symbolic interactions are able to go on at the same time by use of the triangle as the symbol on the signal. The PA pad and the mediator signaler, the three torch signaler, and so if I test it here, red, blue, green, red, blue, green, red, blue, green. So A, B, C. Okay, so this mediator is now working. I use electrical tape to bind together the four wires between the PA pad and the three torch signal sender of the mediator. I have used the oatmeal cereal container to make the tube with the clear plastic end and put the triangle on the end, and so put the 3 flashlights, the 3 LED torches inside. They all have their batteries in them, and they're all in there. And so now this is a functioning mediator made from a piece of wood, a soup can cut into the metal for the sheet metal for the 3 touch plates, 2 32-inch long cuts of speaker wire to go between the paw pad and the 3 torch signaler, and then using the Dremel tool to cut out the switch on the 3 flashlights, the 3 torches, to put in the wires that interrupt the completion of the circuit for the switches on the flashlights, and attach them instead to the control on the paw pad. So that's a complete build of a mediator. I have currently made 6 mediator devices so far, and I have correspondence with Lockheed Martin in their headquarters office. They know that I'd like to do business manufacturing mediators for application for communication signal for a lot of different applications. So A, B, C. The mediator device is quite ready to work. A, B, C. So I have quite a number of them here, and the program on the to calibrate on the PC for the IFR in and out, or video in and out, that can be programmed with the AI to recognize the signal and read it, is fairly straightforward, basic Python programming.